Mark Rendle.
Nice to meet you, Mark.
And I am an Incurable programmer. I started programming 40 years ago. And I'm still mainly programming as a job. That's kind of what I like doing. Working for lots of different companies, generally doing .NET things, and also, charging around speaking at conferences and pathologically incapable of saying no to things. So here I am.
Sounds familiar. Yeah, so I'm Matt Turner. I think I started programming, I was 8. This was before the internet, right? So there was a computer in the house and I got a book, and the book told me it was basic. I got another book on assembler after that, so I could go a bit better.
Which assembler?
Oh, x86. Like we just had like a 386. But yeah, did computer science, and I did my first job was embedded systems, embedded C. I did some .NET desktop stuff for a couple of years, but I've been doing infrastructure, the dreaded DevOps word, I guess, recently.
Infrastructure as code.
Yeah.
And stuff. And you were at KubeCon yesterday.
I was at KubeCon yesterday.
What were you talking about at KubeCon?
I talked about, so I was on the Kubernetes expert panel. I think there were genuine experts on the panel with me, so, Liz Rice and people, Phil Estes, who's the maintainer of Containerd. We got a bunch of questions about all kinds of aspects of Kubernetes. A lot less about how it works now and more about how to use it, a lot more day 2 questions. So that's interesting.
Yeah.
And then the talk was I was on the API track, and the talk, the track host thought would fit the plug in the gaps, fit the narrative was API gateways and why we use them, and how we might move to sort of a service mesh, sidecar, distributed approach for that kind of stuff. So I covered that, but also talked about some like shift left tooling for API development. So I sort of advocated for people writing APIs up front, like doing schema-driven development, essentially writing your API interface up front, and then using a bunch of tooling to lint those definitions and to do breaking change detection and stuff like left in the dev cycle, and then to generate client and server stub libraries from those, so you don't have to write a lot of code, because then you don't need something like an API gateway checking request to response body schema, because you can't send an invalid one.
Yes.
Right? So that's
that's a weird thing. In the .NET world in particular, there's always been a tendency to say you write your service in C# or VB.NET, but and then we'll generate those schema, those sort of definitions from your C# code. And so when the world was doing SOAP and you had WSDL files, you just used WCF and you defined an interface in C# and decorated it with some attributes, and it would generate the WSDL file. And these days, you write your API in ASP.NET Core, and again, we have there's 2 plugins, there's Swashbuckle and NSWAG, and both of those will generate your OpenAPI documentation. But I actually know there are people, including in the .NET world, who are like, no, that is the wrong way round. Your OpenAPI documentation should exist in its own repo, and that is your living document. And then you write your services to fulfill that contract. So, and that's the way you would say it.
That was what I was advocating for yesterday. I think being able to generate those files is better than nothing. There's a big movement where I work. People are moving. Python. I don't care, but they're moving from some Python framework to this thing called Fast API, and one of its features is being able to generate those OpenAPI files from all the annotations. That's better than nothing, because you then can take them, make them into pretty documentation, discover the APIs that are around the place, generate client libraries to be able to talk to them. So it is better than nothing technically, but I definitely advocate for doing it up front, because there's nothing new, right? It's contract-driven development or interface-driven development, whatever you want to call it. It's go to the green light meeting and say, we want to spend 4 engineering 4-person months on building this thing, we'd like the business to invest in this service. This is its contract. This is what it's going to do. These are the SLAs for the sort of performance and reliability of it. And I think being able to take that sort of interface definition there and say, this is the service it's going to provide, even before, and with the meeting with the people who hold the budget, even before you have the meeting with the sort of architect, the principal engineer, where you show the block diagram and say, well, can we build this? Is this even going to work?
Yeah.
I think that mindset shift of what is this service for? Like, what services does it provide to whom? What's its contract? I think that's really powerful.
Yeah, because the other thing I got into recently, in the last sort of 4 years, because it suddenly became a viable option in .NET, is gRPC. And of course, with gRPC, you write your proto files, and then it generates stubs for either the server or the client in whatever language. And someone has actually come up with a way of doing that the wrong way around in .NET.
Right.
But I've been...
Hibernate and stuff was there. I think this code-first approach, because I did C#, 10 years ago. I think all that code-first approach comes from the ORM people, because it was always that you write the database first, they did DDL or the code. And I understand why, especially as Visual Studio was starting to sort of not suck around 2010.
Yeah.
Like, that was a powerful way of getting things done, and they were fighting back against Ruby and all of that stuff.
Yeah.
I understand it. Sorry to interrupt.
But no, so... Microsoft basically put some developers full-time on a project to make a fully managed implementation of gRPC on top of their ASP.NET Core Kestrel engine. It's actually the fastest gRPC implementation except for Rust. Faster than Go, faster than Java. It's very, very fast. You have to write that proto file first and then generate this. The thing I really like about it is that the C# that it generates a base class for you to inherit from to implement the service. And the methods on it are declared virtual rather than abstract. So you override them, but you can not override them. And if you don't override the method, it throws a gRPC not implemented exception, which is really nice. That's the way it should be. Because it means you can sort of write your tests against it, and you can write automated tests.
You really can do that red-green cycle. Write a test, it's red because there's no implementation yet.
And so I do a workshop at conferences and also available for children's parties. 2-day workshop. And day one this is gRPC, this is protobuf, this is how we define our messages and our services. We do that up front, and then we write the code to implement them and go through all that. And then the second day actually is, this is how you run it in production, this is how you do authentication, this is how you build a Docker image, this is how you get it running on Kubernetes, this is how you add linkerd in as a service.
I was going to say,
Because otherwise, .NET has this tendency when you're using the HTTP client, it does a DNS lookup, takes the first IP address it gets, and then that's it. It won't do another DNS lookup.
Oh, even the gRPC libraries don't override that, because that's kind of their thing.
They actually built something into the gRPC library specifically to override that behavior, because they have to do this load balancing thing. But it's not built into regular HTTP yet. It might be in .NET 7.
Oh, interesting. But that's what a service mesh does for you.
Yes, and it does so much more as well. It sort of does heartbeat checking, so it doesn't wait until you're trying to send a request to go, oh, that service isn't there anymore. And it's sort of building on the mutual TLS authentication and everything. So
I got a question yesterday about service mesh plus gRPC, and I was like, right, so HTTP is dumb unless you write, a lot of the client libraries are very dumb unless you write a whole load of code, which you don't want to do, so you get a service mesh. I said gRPC was designed to be this fat client library. It does client-side load balancing. It can even talk to a look aside, load balancer thing. It does, because it's requerying DNS all the time, basically. It's essentially, the health check is like in 3 stages. It's go check with the service discovery system, even though that is usually DNS. But it is pluggable.
Yes.
Other service discovery systems are available. It does active health checking by pinging and making sure that channel's still up, and it does passive health checking by seeing if 500 start flooding back, then it'll just drop that one out of the pool. So it's trying to do all of that stuff for you because this person had deployed Istio with it. And I'm like, right, so all of that goes out the window when you've got Istio, because Istio's going to do it for you.
Yeah.
And that's great. That's a great addition to HTTP. It's like you actually need to configure both of them in such a way that they don't fight.
Yeah.
But yeah, gRPC had all those ideas.
Well, Istio terrifies me.
It's complicated.
Because it's like, I knew for this workshop that I wanted to demonstrate a service mesh, and the problem, because certainly the .NET Core 3.1 and the .NET 5 versions of gRPC didn't do that client-side load balancing.
Right.
And so you did. The problem is the DNS always returns the addresses in the same order.
Right.
And so you've got 5
to that
instances
one.
of a service running, and then all the other things are talking to that one instance, and these 4 are just sitting there going, this is quiet. So yeah, and I was kind of like looking
the
through
WebSockets problem.
How to set up Istio, and in the context of I want to spend 2 hours on this maximum in a workshop, like between a coffee and a lunch. And then it was, how do you set up Linkerd? Well, you download the Linkerd binary, and then you do Linkerd check, and then you do Linkerd install, and then you do Linkerd inject into your YAML file that you've already got, which basically adds a single attribute to your service.
Oh, it adds an annotation, and then they use a mutating webhook
That's
later.
basically it.
Yeah.
And then suddenly you've got a service mesh running, and it's got Grafana built in, and it's pumping things out to Prometheus and all this. And I'm just like, this is magic.
They built this is sort of the glib rendering of it, but they built a product, and Istio built a platform.
Yes.
I think Istio saw Kubernetes, and they've obviously Google have gone and built Anthos and whatever on top of it.
Yeah.
It's built into OpenShift, so I think there was a difference in approach there. I mean, I do Istio workshops, and the first, you've got to get people up and running with the Kubernetes cluster first, right? And they may not have seen it, or they may just have one provisioned by their IT department. So it's Minikube, but I just that's not part of the learning. I just want that to be done. So they bring a laptop they've got root on, and I give them this long Minikube command that gets all the little options right.
Yeah.
I just run it and trust it, fine. But then Istio, actually the first exercise, the first couple of hours of the workshop is like, right, we're going to install this thing. And I could have given it, so Istio has got better. You can now istio-ctl install. If you want it to have the Grafana and do a bunch of useful stuff out of the box, you've got to give it like a profile file, like a YAML config, basically. And it took me a while to work out exactly what all those options should be for the purposes of the demo. I was like, I could just give them that, but actually, no, you need to understand this. A big part of this is understanding what these options mean and what they do. So we spent like an hour or two. The morning is basically get a kube cluster, have a copy, install Istio.
Yeah.
And I was like, this is actually, I think, valuable learning. So maybe it shouldn't be like that, but
no, if you've got the sort of infrastructure engineering resources, and you've got very specific needs, then I think Istio gives you a lot more sort of points where you can hook into it and configure it to do. Linkerd is just like super opinionated and goes, this is the way it works out of the box. That's probably okay for 80% of use cases.
I would agree with that. I think both definitely have their place.
Yeah.
I should maybe syndicate your workshop then, do the Go version.
Yeah.
It sounds like I think gRPC and that approach is just a great way to do.
Yes.
A load of things. And explaining to people that the name is actually quite bad. So to me it's a transport, right? Protobuf is a good encoding.
Yeah.
HTTP2 with the multiplexing and the no head of line blocking and the generated stubs is a great way of punting messages around. What you build, or the API you build on top of that, can be RPC, like OOP, send a message to an object that's got hidden state and ask it to perform services.
Yes.
Encapsulated, proper 90s stuff. Or it can be CRUD. Like, it doesn't have to be an RPC style interface. It can be a REST CRUD interface where you move whole objects around.
You can basically go, here is a thing, here's an update method, here's an insert method. You can do that.
Yeah, and I've had that conversation with people who say, I don't want to do gRPC because we believe in REST and everybody's used to CRUD, and I've had bad experiences trying to write RPC because you get consistency problems. And I get that. It's a bad name. you can do CRUD if you want.
It's kind of HTTP on steroids with bidirectional streaming.
Yeah, and the streaming's so useful.
Oh, that's great. I love the streaming.
Because what's your alternative? Deploy a Kafka or use WebSockets? Give me some streaming that works.
I remember my first encounter with gRPC I was working in Canary Wharf. And they had a WPF application that took so long to start up that the users would get to their desk and they would turn the computer on and they would double-click the icon to start the application, and then they would go and get a cup of coffee.
Wow.
And this is at 9 o'clock in the morning, so there's a queue for the coffee machine. And they get the cup of coffee and they come back and it still hadn't started.
Wow.
And so I'd done some stuff, and I love performance. I love trying to squeeze extra performance out of finding out why things are slow. And so they said, "Oh, please take a look at this thing. We've got a bunch. The entire team is currently focused on trying to make the thing faster." And so I joined the sort of sprint kickoff meeting for the next sprint. And they were going, "Well, I think it might be this, I'm going to try that, and I think it might be this, and I'm going to try that." And I was like, "Well, have you got any measurement in there to see sort of which bits are taken?" And they said, "No." And so I said, "Can I instrument your code?" And so I got them to let me set up an InfluxDB database, because it needed to be push. We couldn't use Prometheus because you can't have Prometheus talking to WPF applications.
Right, this is more recent than I thought, given the problems I was like, is this spinning Rust hard disk and stuff? Like, okay, Prometheus dates it. This is more recent than
this
should have been.
This was, so it was one of those things where the application basically they'd started on it literally when WPF came out, so like 2005, 2006. And so it was more than 10 years old by the time I got to it, and it had just grown and grown and grown. But anyway, so I put diagnostic bits all over the place and stopwatches, start a timer, stop a timer, write that to Influx and so forth. And then I presented my results and they said, "Oh no, your measuring's wrong. This is showing as making 20,000 individual calls to our gRPC service. And it doesn't do that. It makes one call to the gRPC service and then it streams back 20,000 results." And I went, "No, it doesn't. No, it doesn't. It creates the client, it makes a single call, and then it disposes the client, and then it loops around and it does it again 20,000 times." And they went, oh, we should change that, which immediately knocked 2 minutes off. And it just, to me, that really highlighted the importance of measuring and monitoring and this observability thing. And so now my next workshop, I think, is going to be on OpenTelemetry. Which is just huge, and everything just supports that, like out of the box. All your platform as a service things.
So. I was going to say trace bands are a really good way of getting observability into things, especially with the service mesh. You deploy that, you get there's traces on the network, so into service, service to service hops for free, and then instrument within your application. So okay, a request has come in, like I've seen it hop the network because the service mesh has told me I'm now going to actually use the library, so the client library for OpenTelemetry, to instrument my own code so I can see the hops through the major parts of the service. And then you get this, when your user request comes in, you see inside service A, over the network, inside service B, and you get this one, you just propagate the context and you just get this one trace. And it's really, really interesting because, people, it's the network, that service is slow. Like, no, it's not our fault, we call the database, we have to block, And you just get that whole visibility in the same tool as well. Like, it's not, infrastructure's slow, no, the app's slow. Like, well, here's this.
Here's everything that it could possibly be, and look, this bit's long and this bit's short, and
being able to see inside and out is really, really useful.
And you can sort of, because you've got the network call, and then say you're using gRPC, you can actually see the sort of milliseconds that it spent decoding.
Yes, it's library.
The streams
the better gRPC libraries do actually emit, because they don't all, do they? But the better ones emit spans for decoding.
And in .NET, Microsoft have gone really weird. So, because I've been doing .NET since 2002. And you used to get your performance information out of .NET via event tracing for Windows, and you'd have to go into, because it was all Windows all the time.
Oh, like the Windows event? It was just like the Windows event viewer?
Yes, so you go into event viewer and you go into perf view if you wanted to find out about garbage collection cycles and so forth.
Wow, right.
And then when they did .NET Core, they went, oh, we need to find a way of doing this on Linux.
Yeah.
And so they actually built in this whole diagnostics pipeline. And then when the weirdest thing, I think, in my entire experience of the computer industry, so you had open tracing and open census, and they defied that XKCD comic and went, no, let's combine them together into one. And so now open tracing redirects you to open census, redirects you to telemetry. And yes. And Microsoft basically went, well, we'll make what we built in .NET compatible with open telemetry. It just has a different name. So what open telemetry calls a span, .NET calls an activity. Yeah. But they're basically the same thing. They've got baggage, they've got...
But the wire format's compatible.
And yes, exactly.
That's what's important.
And you drop in an open telemetry library, and then it's got automatic instrumentation for the HTTP stack, both sides, client and server, for various databases, Redis, gRPC's got its own one. And yes, and you just go, here's a Jaeger host. Dump it all out.
Yeah, send it over there.
It all just magically appears, and then you're kind of going, and I can figure that Jaeger host into Linkerd as well.
Yes, yep.
And yes, no, it's kind of magic.
Yeah, no, it is good. That stuff's got a lot better.
So what year did you start professional?
When I graduated, 2008.
2008. So that's like the same year as AWS first started renting out.
Yeah, I guess it is.
EC2 instances, isn't it?
Yes, it is. I didn't touch AWS for a long time after that, but yeah, I guess it is.
Yeah, because I've been going 18 years by that point. I'm so old. But it is...
It all comes in cycles. How long do you think the cycle is then? Because all of these things get reinvented. We've got Kubernetes, isn't that great? All these kids running around at conferences. Like, have you heard of Erlang?
Oh.
Like, how long is that? How long is that cycle? I want to say it's sort of...
So when I started in right at the beginning of 1990, there were 8 of us working on a Tandem 286 running SCO Xenix. Wow. We literally had a table tennis table downstairs because the build took 3 to 4 hours.
Well, that XKCD of my code's compiling.
Yes.
Used to be a thing.
That was absolutely a thing.
Computers
we had literally thousands of lines of code, so obviously it took...
Well, the embedded C, the first job was C, and we had maybe 1 million lines with all the vended libraries, and there was no cloud, there was no real way to do that.
And it does take a long time to build C.
You could have had some kind of build box in the server room maybe, and we did try it, but it was difficult, and so I basically had a super overclocked Pentium 4 under my desk.
Yes.
IT bought the most expensive Pentium 4 they could get hold of. I'm a gamer, so I went in one evening and overclocked the thing, because they'd overspecified these machines. I think they'd just got them from some supplier, and they had a big copper. I took the side of it once. It had this big copper heatsink. And there's obviously this sort of gaming orientated motherboard because you just had to get something that could deliver 280 watts right to this stupid Pentium 4. So it's like, this is clockable.
Yeah.
I got about 5 gig out of it, 5.2 was like stupid. Like it did used to make a lot of noise when it ramped up, but it got my build time down a little bit, but you would go and get a coffee.
Yeah, yeah.
But like you were saying about the WPF thing, I remember that we had a kind of similar problem. Second job, the C# place, would walk in the morning, press the button on the computer, because we turned our computers off overnight, right, for energy efficiency. Would walk, but it was still desktops, if anybody remembers what they are. Would walk in, press the button, and then it would, have to go and get a coffee while the thing started up, because it had a spinning Rust hard disk and whatever.
Yeah.
So one week, we were like, right, this is silly. And we built a little thing that plugged into the DHCP server. Mm-hmm. Spotted when, so there was Wi-Fi and there were smartphones just about.
Right.
So you would get close to the building, your phone would join the Wi-Fi network, everybody's MAC address was in a table, it would recognize like, oh, Matt's phone's joined the Wi-Fi network, there's his MAC address that he's registered, he must be getting close. It would send a wake on LAN packet to your desktop, you would walk into the building, say good morning to everybody, get a cup of coffee, and then by the time you got to your desk, you were sat on whatever it was, Windows 2000 login screen.
That's genius.
Yeah,
that's a fantastic.
It wasn't my idea. I can't claim that idea, but we did the.
Can you make this application start faster? No, but I can make it start automatically from 200 yards away.
I can make it magic. How about that? Would you like some magic instead?
I love that.
It was a fun time. It took us because it was a fully Windows estate, so it took us a long time with Windows Server, Windows Domain Controller, DHCP to do the practical parts of it. But it was great. It was a good fun week.
I remember when I first got into Windows. So talking about the cycle. The application I was writing for like the first 5 years ran on Wace terminals on Unix boxes. And so you had what ANSI graphics could draw lines around things and stuff.
Curses.
Yes, end curses and all that. Writing C code with SQL embedded in it between dollar signs. Mm-hmm. And then we went to Windows, and then everything was suddenly client-server. So, but in a sort of, all the logic was in your desktop client, and there was just a shared database on a server somewhere.
Yeah.
And then
all the actual logic.
Sorry?
You're good that the logic was on the client, because I've seen a lot of those where there's the client, and then all the logic is in a stored procedure in the database server.
Those two. And then the web came along, and then we were suddenly going, oh no, all the logic should be on the server as well, using SOAP and XML and all that sort of stuff. And then once browsers got a bit smarter and you could do better things, so again, probably in the mid-2000s, you got to this thing where all the work was being done on the server, and it was just spewing HTML out and sending it down to this dumb client. Yeah. And I think that's a cycle, because when you're on one of those VT100 or Wace terminals, right at the end of the 80s and start of the 90s, you had a central process that was just sending the characters to display to a TTY on the system, and then the internet was essentially the same thing. It was sending HTML to say to the browser, here's the text and images and stuff to display.
What's a Chromebook if not a mainframe terminal?
Exactly.
Really? But it's gone back the other way, so we don't server-side render anymore. Like Jamstack is cool.
So and
I guess a lot of the compute is actually done server-side, but all the rendering heavy lifting is done.
But it's done another cycle, because it's gone. Then everyone was kind of like, oh, we got to write single-page applications with Angular and all that sort of thing. And then, like you say, now there's Jamstack, and you've got Next.js and SvelteKit and Angular going server-side rendering.
So
kind of like. Weren't you the ones who told us to stop doing that?
The clients told us to combine to your API and
yes, and the cloud. Back in the first sort of 10, 20 years of my career, if you wanted a new server, it was fill out a form and justify it and go to like 3 meetings to explain to increasingly senior people why you need a new server, and then it would take 6 months for it to get built and shipped to the data center and installed, and now it's kind of like
there's an API on that,
or AWS CLI or Azure CLI or whatever.
Terraform
Terraform, Pulumi.
Yeah,
you played with Pulumi much?
Yeah, a little bit. I don't really like the model
too
much. It doesn't work for me.
I think Terraform.
I like Terraform.
Terraform's the thing that you've got to displace now, isn't it? It's the sort of Terraform's the obvious answer, and if you want to come up with a better way of doing it.
I saw a really interesting talk from Crossplane yesterday, which might actually maybe be the answer. But yeah, I like Terraform because it's not Turing complete, right? It's declarative. It's a config file basically. It says I would like there to be these, and they're deliberately staying away from. They've added a few more features, but there's no loops, there's no logic. Pulumi is like. And AWS CDK and all these proprietary ones, they're like a library. They're basically like libcloud. So they're like write logic that's just going to make API calls to Pulumi, and then Pulumi will make cloud resources. I find inevitably people just shoot themselves in the foot with that. You just give them that sort of Turing complete logic to to drive that thing.
And do you really want to be creating high-performance compute clusters in a loop?
Right, exactly. And then people were using it, so people were doing nice things. People were trying to reconcile with it. So I remember Terraform, and there was this Weaveworks tool called like TerraDiff back in the day. I think maybe it's not been maintained. Because Terraform it's one shot, you run it once, and then maybe there's some drift. I'm sure you remember database drift problems back in the day, right? As SQL compare and all that kind of stuff.
Oh, I've written a couple of tools for that.
Yeah, no, I used to work at Redgate, right? So SQL compare, SQL source control stuff. And it was a real problem. So you'd apply Terraform, and I was like, I've seen this all before. Deploy to a database, and it goes awry. So there was this TerraDiff tool, and you'd have it wired up to an alarm, which would say, oh, the clouds drifted from the Terraform, I think. So people were quite rightly trying to use Pulumi. I saw a couple of examples of trying to just keep running that in a loop, right? Keep reconciling. But I think people would pollute that with a lot of decisions. So crossplane, they'll shoot me if they watch this. I'll probably completely get it wrong, but it's kind of like a Terraform form. You give it Kubernetes style YAMLs, but it's a declarative declaration of what you want as like a static thing, but then they run that reconciliation. You feed it into the system that then runs a reconciliation loop and just keeps it on course.
Yes.
Seems to be a nice model.
Because I've just started working with this startup, Polyscale. So they are Cloudflare for databases.
Okay.
If you've got a database in sort of the United States data center somewhere, and you're deploying code that talks to that in a UK data center, so you've got sort of edge API locations, but one central database. So Polyscale sits as a sort of proxy / cache in front of that database and caches the results of queries.
It sounds like a read replica.
It basically, yes, but much simpler than a read replica.
Okay.
So you hit it with a query, and it goes, "Oh, I've got that. I'll just ping that straight back to you." Or I haven't got that. I'll get it and I'll cache it, and you can say time to live is like.
I was going to say, how do you do cache expiry?
So two ways. You either specify time to live
from the client
manually at what they call the POP.
Right. Okay.
Or it's got smart invalidation. So if it sees an insert, update, or delete, because you're proxying every call to your database through this proxy.
But only from that region.
But only for that region, and then you might not use it in the other region, but you might use it in a single region just because you've got a read-heavy database and you just want to take some load off the database so you can run it on a smaller instance size or something. But yes, anytime it sees data manipulation queries going through, it just invalidates the cache. It just goes, that table's been updated, I'm invalidating all my cache that uses that table. But they, obviously the sort of key thing when you're doing something like that, they're early stage startup, they've just got a good round of funding to sort of expand and do some marketing and stuff. So they've been pretty much stealth up to now. But one of their sort of key things is we can, at the moment we've got public POPs in 8 Amazon data centers, seven or 8 Amazon data centers.
With like a VPC, with like a partner, I guess, and you can VPC peer to them.
Yes,
all that good stuff.
But if you say, oh, you don't have it in Australia West, or you don't have it in this one, they can spin it up in an AWS data center, spin up a whole POP in 20 minutes, because it's a combination of Terraform to create a Kubernetes cluster, and then just Kubernetes files to actually run the code. And then it's self-updating because they've got something running inside the cluster that checks to see if new images have been released.
Flux or something.
Yes.
Argo,
and it's absolutely insane. And you just sort of think, and I can spin up a server anywhere in the world to do this, and it's
crazy. And ironically, we've kind of come full cycle again, because you can't, if you try to buy a server now, you can't, right?
No.
Because of the chip shortage, because all the chips are going to GCP and AWS basically, because the chip manufacturers have to keep them happy. And yeah, you kind of have to have somebody else's server.
Yes.
That was kind of my route into DevOps. It was interesting. I was at a big telco provider and was a software engineer, but ended up, the classic case, I guess, if there was some infrastructure needed doing and nobody else was around to do it, so I sort of picked it up. Kind of wrote, I would blow my own trumpet, I mean, it's not as impressive as it sounds maybe, but sort of wrote a Terraform before there was a Terraform, just from, this thing at least had it was OpenStack.
Right.
Which was, yeah, let's not go there with PTSD, but it was OpenStack, which is a very early EC2, because EC2 follows a lot of the OpenStack APIs.
Yes.
OpenStack was the first thing in Amazon actually when they were a small player, and they copied the OpenStack API. But anyway, it's the first kind of, you ran it on your own data center, you bought the hardware, but it was VMs and VXLANs and storage volumes with an API on the front, right? Very early sort of on-prem cloud. So you could you could click through it, but I was like, I'm a programmer, there's a CLI, so I sort of wrote the CLI, and then before you know it, you've got a script, like a bash file that's just batch.
Yeah.
And then you get some loops in it, and then I was like, this is a bit, what I want to be able to do is write, I want to be able to reuse this stuff because it's all hard-coded, I want to be able to write descriptions. So it was in bash, I had this thing where a load of bash scripts, and then you would write end files, basically, if you wanted like this kind of VM and that VM and that VM, you would have a bunch of files that would literally declare bash variables, and this script would go through source one and apply it and source one. So I kind of wrote Terraform before Terraform existed, but it was really shit and in bash. And then did almost the same thing with, I don't want to say Kubernetes, but we had more bash that would take tarbors and extract them and and all of this was my kind of route into the DevOps stuff, was seeing these kind of problems and making tools for them.
Yeah, there's a serverless, an open source serverless thing that I think is largely written in bash that schedules things.
It's the Kubernetes, what's it called, meta controller or something, where you want to write a controller because it's client Go, right?
Yeah.
But they've just brought that out to a nice interface, so it's you can hook it with any language you want. I think it just makes you REST calls or something. No, I think it executes a directory of hooks. Maybe it just executes anything with an X bit set. You just give it a directory, so you can write, Ruby or whatever. You can totally write bash. You can totally write controllers and admission webhooks in bash. You maybe shouldn't, but you can.
Probably should. But Kubernetes, because talking about the cycles, and you've got sort of cycles within cycles, but in the mainframe days, you would write your code, and then you would ask the mainframe to schedule it to run. And it would sort of sit it running in a background process, or it would run it once and give you the results and all this sort of stuff. And so Kubernetes is basically the modern evolution of the old mainframes.
Yeah, sort of. I would say maybe more like a Plan 9, because people are saying, Kubernetes is the new POSIX, and it is this interface that you can sort of write systems against. I would say it's maybe more like a distributed, like a normal, like a multi-processing operating system. I totally take
Plan 9.
Like Plan 9, I guess, like a very networked, because I totally take your point. I think that if you see a lot of the high-performance compute stuff that's going on, a lot of the like big batch processing. So CERN did a KubeCon keynote, because they did their number crunching for the Higgs boson stuff on a massive Kubernetes cluster.
Yes.
And they did a keynote where they explained it, and it was really good, and they actually had the cluster idle, and they ran it again. They rediscovered the Higgs boson. They set it off at the start of the talk, and by the end it crunched enough numbers to do it.
That's quite impressive.
It was very cool. But that was Kubernetes with a lot of the moving parts replaced. So the scheduler, for example. So you see the people like CERN, a lot of the financial institutions who are doing batch runs. They're even using heavily modified Kubernetes, or they're still on Slurm, or one of these other sort of batch processing, OpenMP, or one of these other batch processing systems. And you can make cubes so extensible you can make it do that. But
the processing power now. So I did some work for McLaren Racing.
Oh right, yeah.
Way back in the very early Azure days. The rules, Formula One keep changing the rules to try and make it possible well, to make it so that the teams with huge amounts of money like Ferrari and Mercedes aren't just buying championships, so they sort of put limits on how much you can spend.
Well, this year's been a big reset as well of the rules, hasn't it? So everybody's starting from a clean sheet.
But back whenever this was, they put a limit on the amount you could spend on computer hardware.
Oh, interesting. Those were the days of crazy aero, though, weren't they? I guess that was why they were doing it, because if you can't afford a wind tunnel or you can't afford a supercomputer, you were just really out of luck. Yeah.
But when I turned up, they had MATLAB running in what they called their MATLAB data center, but was actually 8 laptops in a cupboard. This is McLaren.
Right. Yeah.
This is McLaren racing. I'd go in sort of every day I was there, and you walk past sort of Lewis Hamilton's race-winning McLaren and Bruce McLaren's orange monstrosity with a sort of aero wing 6 feet up in the air.
Oh, that was one of the F1 like GTM.
Really, when it was just the Wild West of racing.
They seem super high tech because they 3D print titanium and they do all kinds of stuff.
Yes, they've got this bonkers stuff. But yeah, people would submit their MATLAB programs to this internal batch processor, and they would run overnight, and they'd come in the morning, and their results would be done. And I understand very little of maths.
Same.
And I certainly don't know any MATLAB, but I knew about Azure, and so I managed to create a compute image template that included MATLAB and ran the installer and managed to apply a license key.
Yes.
And so it went from 8 laptops sitting in a cupboard to how many machines do I need to spin up to parallelize this so that I can get the results in under an hour? Because at the time, Azure charged, if you had a machine on for a second, it charged you for the hour.
Right.
And so it was, how close can I get that to like 59 minutes and 59 seconds?
But not
shut them.
Not 1 minute, 1 second, because you've doubled your spend.
And so I think it was sort of estimated at 55 minutes was your thing. So if it ran over a bit and you had time for the startup and the shutdown and so on.
That's very cool.
But yeah, and it was just spinning up 100 machines just to run one person's thing.
Yeah.
But it was 100 hours. And Microsoft obviously sponsored McLaren at the time, so I'm not sure they were paying for their Azure.
Interesting. But how much compute do you want?
And now you've got sort of these Kubernetes clusters, and you've got nodes with NVIDIA GPUs installed that are just crunching through machine learning.
Intensive processing units and more. I wonder whether any of the crypto people have ever used Kubernetes, because you get these more and more specialist hardware, right? So originally you mine crypto on a CPU, and then we're like, a GPU is the way to go because it's a more specialized, and then it moved on to ASICs quite quickly, right? Actually specialized circuit. They're literally just hardware that FPGAs or fabbed chips that just did the right kind of hash algorithm.
Yeah.
I wonder whether anybody ever used Kubernetes as a control plane for that. But
probably.
I'm just thinking if that's maybe where the financial start on whatever is going to go, because they've gone from CPUs to GPUs. There is a reasonably new Kubernetes feature about managing arbitrary, because those things are finite, right? You've got like a certain number of GPUs or whatever plugged into a box.
Yes.
And you need to allocate them to be, the scheduler needs to know that, this thing is full, not in terms of CPU and RAM, but in terms of it's got 5 ultra-fast NICs or 5 graphic cards or something, and like a pod has to have precisely one, has exclusive use of it, because they can't be virtualized. So that's recently been extended to model any other kind of like finite hardware you can think of. So I do wonder.
This is this is the stuff that makes me just kind of there's levels of knowing Kubernetes. And my level of knowing Kubernetes is I can write a deployment and a service, and the deployment creates one or more pods, and the service exposes it to the rest of the cluster. I can work with the secrets, certificates, but the very, very basic stuff.
You want to watch my LinkedIn learning courses on Kubernetes?
I will.
No, I've been deep.
Yes.
Having done OpenStack and having written a web browser, that was the first job, it's not bad. It's not bad. There's some complexity. The complexity is usually necessary. Like Go is great in some ways and really doesn't help in others. There's goods and bads, but it's not bad.
Yeah.
But yeah, no, I've been deep, and you see some things, and then you come back and you be like, that's why it works like it does. Okay.
Yeah.
That explains the slightly odd behavior that I'm seeing. Is because of this weird nut and bolt down there.
Yeah. But the thing I find really strange with Kubernetes now is it became. So it's not just this is Kubernetes, because you've got micro K8s, you've got K3s, K0s.
Yep.
Is that a thing?
That is a thing. And then the Minikube and kind.
And yeah.
And then the distributions, the OpenShifts and whatever of the world.
So you've got different implementations. So Kubernetes is basically now just a standard.
They're all based on the same code. So the Kubernetes API, I guess, is a standard, and it could be. And you do get people re-implementing schedulers and stuff to that standard. All of the things you talked about are actually the same code base. They're more like distributions. So
like Linux distributions.
Yeah, K3s, K0s are designed to be small. They statically link it all into one binary. They skip It's like a small Linux distribution that you mostly just drop drivers, right? The first step to shrinking your Linux is to know what hardware you're targeting and just strip all the drivers out that you don't need, right? Yeah. And then only after then do you start taking more important things out of the kernel, right? Like maybe even for microcontroller Linux, like the memory manager goes because you have virtual memory, right? And you at some point you go from hot plug to like device tree and all that.
Yeah.
So yeah, K0s, K3s are just small. They strip components. They optimize the build. The distributions, things like OpenShift actually add stuff on top. Different controllers and stuff. They are all, as far as I'm aware, they're all based on the same code base.
But
nothing to stop people re-implementing it. But
yes, you could if you wanted to implement the same APIs using Rust, and
you absolutely could. Although, and there's very good Rust bindings now for writing controllers.
Yeah.
You could rewrite the core bits in Rust. The scheduler, the bottleneck with kubecluster scaling certainly used to be etcd. Actually, it's a database. That was the one thing that was hard-coded into Kubernetes in the early days.
Yeah.
The API server code especially used the etcd library without any kind of sound in front of it in a whole load of places in the depth of the code. And a lot of work was done to rip that out.
Yes.
And to make it pluggable. So now I think I'm right in saying K3s uses SQLite.
Yes, I think it does.
Something like that. So that's now replaceable, and actually it's happening in both ways. People are using SQLite and stuff, even maybe in memory stores for smaller clusters, bigger clusters, because that was usually the scaling bottleneck, using some replacement. I think there's maybe a facade that lets you use Postgres and then you can scale out or something. I don't quote me on it. But that seems like the first place you'd go. You'd use TIKV or something, right, and just go Rust there, but no reason not to re-implement the rest of it. Because
one thing I was looking at was I have this notion to take down Facebook. Someone has to. And the idea is build a social network where you eventually buy something like an Amazon Echo device, a thing that goes in your house and you connect it to the Wi-Fi, and then that's your node of the social net. And so your updates and your photos and everything go onto there, and then you can connect to other people's nodes in their houses, and it sort of constructs the feed and everything. And the front end would just be like a SPA that's then using OIDC, OpenAuth, and adding a friend is just adding an allow list. Yeah, exactly. Like a group. It's kind of like, so your friend goes, I want to connect with you, and you're, I will allow you to connect with me, and we'll do a key signing. We'll do a key. Here's my public key, and you go, here's my public key, and then when you want to exchange information, you use public key encryption, and then they can decrypt it on their side using their private key that they've still got, and all that sort of. So essentially, and then expose all of those things to the internet using Cloudflare tunnels. Until Cloudflare asks me please to stop because I've got 1 billion users and they can't handle it. That'd be a good problem to have. Be a good problem.
I'm sure there have been attempts to do things like that, decentralize it. Maybe not as going as far as you're suggesting, but using torrent essentially or something like that, just to keep the information either in the individual's hands, like you're saying. I mean, maybe you do like encrypted, N+3 replication for backups or something.
Yes.
It'd be encrypted by your private key.
So my idea for as you add a friend who's in another location, you would basically go, that friend I trust. And so can you please, and they've said that I can use their node for backing up my data or for making my data accessible in the case that my internet goes offline.
Right.
But anyway, and the idea is to write the sort of software as open source and distribute it as an image you can install on a Raspberry Pi and get geeks using it first, and then go, hey, look, this is great, and then get funding, and the business model is selling the devices, selling the hardware, so it's a hardware business rather than a software business. But obviously coping with updates and things is challenging when you've got a piece of software that's running, and then you need another piece of software running to see if an update is available that can then download it, somehow install it while that one's still running, and then seamlessly switch over. It's actually easier to put K0S or K3S on a Raspberry Pi, distribute the software as a Docker image, and then I found out that you can actually use the .NET Kubernetes client to talk to Kubernetes from inside the cluster.
Oh yeah,
it's actually its default behavior. Is if you don't give it any other information.
Yes, it'll discover the cluster it's in.
And you can literally just go, hello, I'm running. Do a rolling update with this new version of this image, and then I'll die. And Kubernetes just takes care of all that complexity for you.
It does. The cost of using some resources, like you could use CoreOS or Flatcar or something and take it back a level and do your own rolling update orchestration. But because then you've got the Docker host, but you don't need the rest of Kubernetes. How do you update Kubernetes though? Who watches that watcher?
Well, I don't know. Do any of those? So I guess if you used Ubuntu, you could use micro KTS, which is a snap.
Right.
And then you can just snap auto updates.
How do you update Ubuntu?
How do you update Ubuntu? Well, eventually you say to people, you need to buy a new piece of hardware.
Business model sounds flawless.
Yeah.
No, sorry, I'm being facetious, but I mean, you do. I mean, do you want to know how sort of switches and like these kind of embedded systems usually do it? They normally, it's not seamless. That's the thing. If it doesn't need to be, you normally would have two partitions on the disk. The software is sort of built into an operating system. You're basically like a snap, right? But a whole operating system image that you just like copy onto disk.
Right.
So you would bundle, if you're talking about like a switch or a router or something, you take the packages, whatever, you install into Linux, you snapshot the disk. You have two partitions, you boot off partition A, and then the update is partition A is doing its thing, routing packets, but it'll also download the new image, dump it onto partition B, and then you just reboot. You reboot into B. If for some reason there's a problem, it doesn't start, like the firmware is clever enough to go back to A, but then you're running off from B until there is another update, B will stream it down, write it to A, and then you flip over.
Cool.
And then if you need seamless upgrades, well, if you need zero downtime, you just have two of those running in a pair, right? And while one's doing the flip over, the other one takes over.
Well, obviously, the zero downtime hardware will be bigger and more expensive.
Yes.
So
premium. Yeah.
Yes. So
MacBook Premium.
My idea is that we sort of start off with literally just like the Amazon Echo Puck style thing, which you can only access through a browser interface, and we sell them in packs of 6, so that people like us buy a pack of 6 and then just, here's your Christmas present this year. We're all getting this. You're all signed up. But then sort of Robert Scoble and Elon Musk can just buy like the Ferrari version of that with sort of a terabyte of solid state storage and multiple redundancies and all that sort of thing. But anyway, the software bit of it's going to be open source. So when the time comes, I'll just ping you and you can go, so this is that dual partition.
And Rust.
Things. No, not Rust. .NET. Because, you can now.
Yes, you can.
.NET is cool now.
Yeah.
It's got a real image problem. It's And
So
Microsoft.
like Java is always going to have that image problem.
Yeah, that's the thing. It's kind of
C Sharp's a good language. I mean, Java, the JVM. I think people are always going to remember the performance problems and stuff. It's a tricky thing.
Yes.
But I think Java's always going to have the image problem, but it's fine because Kotlin's just better.
Yeah.
Like we tried Scala. If you like functional programming, fine. If you've got a team of people who know Scala really well, you can get some great stuff done, but it's basically unreadable unless your head's really in it. I mean, I write Scala and I can't read my own Scala six months later.
It's what they call it once, isn't it?
Yeah, Clojure, I mean, you brackets, yeah, you did Lisp at uni and you want to keep doing that, all right. But Kotlin, very solid language. Works on the JVM. C Sharp is, we don't need another one. Like C Sharp is a good language.
Yeah.
And Anders Schilsberg or whatever he is, or whatever the guy's called.
Anders Hausberg, and now it's Mads Torgersen took over because Anders went off to do TypeScript, which has also been very successful.
Yeah. No, it's good language, and yeah, I hope it can shake that.
Yes.
Because it's getting gRPC, and as you say, they're doing it properly. It's not like an afterthought like it is in some languages.
No, it's properly. But the really nice thing is you can actually run. So you can run an HTTP API. You can run. So gRPC web.
Yeah.
Which is the thing. So that browsers which don't implement HTTP2 properly can actually talk to gRPC services, which normally you run as like a proxy Docker image. In .NET, they've implemented it as middleware. So it literally hooks into your HTTP pipeline and then talks back to the gRPC service, which is running in the same process, just by calling it, and then returns the results back out. And then in .NET 7, they're implementing gRPC JSON, which is this new thing where
it just does JSON encodings of the protos, basically.
Yeah,
right,
it's basically replacing the protobuf with JSON, and I think doing something with the UI anyway. But yeah, so browsers will be able to talk to that as well.
I would argue that middleware is actually not the right place for that, but it's kind of Microsoft thinking, maybe.
I may be slightly responsible. So have you ever done Ruby?
A little bit.
So you know rack?
Yeah.
And Python has WSGI.
Whatever it is, yeah.
And it was this thing of building up sort of middleware things. Yeah. And so a bunch of .NET people, including myself, went, we should have something like that in .NET. And so we defined this standard where essentially the HTTP request was a map or a dictionary, and the response was a dictionary, each with potentially a stream if there was a body. And then you could build up this middleware thing, which we, at one point, because we were trying to make it work with .NET 3.5, I think, which didn't have tasks.
Did it not? No, it didn't.
No, it didn't.
Wow,
tasks were .NET 4. And so rather than having tasks, we had a lot of callbacks. And actually, we called it the delegate of doom. And if you had 80 columns in your code, just the definition of this this delegate was like 5 lines long. And then we went, you know what, that's stupid, let's just use tasks and make it .NET 4.
Yeah, it's doing gRPC on .NET 3.5.
Exactly. But then Microsoft kind of implemented the official version of that, which was OWIN, the Open Web Interface for .NET. Right. And then when they did .NET Core, it was essentially an extension of that. So they used the same thing. So we have middleware pipelines, your authentication, and then static files.
I didn't realize .NET didn't have one. Definitely not arguing with that, to add logging and crash handling and stuff. Yeah. I'm not sure gRPC is.
But they stuck gRPC in there as essentially. I don't think it's middleware so much. You've also got endpoints, so you've got multiple endpoints, and routing deals with them and all that sort of stuff. But and like I say, it's the second fastest gRPC implementation outside of Rust.
Wow.
And it's not that far off.
Okay.
And you don't have to write Rust.
I like writing Rust.
Everybody loves Rust, but it's terrifying. It's the quote A, the lifetime thing. Lifetimes. I've got ownership. I struggle with lifetimes. I will get there. I just need to write something real in Rust.
Yeah. I think I get the concept, but I actually practically applying it, like actually doing it.
Yeah.
It's like, you stored this and you made a thing, and then you, stuck it in a linked list on the heap, and then you're getting it out again.
Yeah.
Like from a different HTTP. So your HTTP handler, you make some data, you save it on the heap, obviously because you've got a pointer to some tree or linked list or whatever data structure, and then you want to get the thing out again. Yeah. It'll only let you do that if you can prove to the compiler that it's not going to get dropped, because there's no GC. Like you've got to prove that it's not going to get dropped.
Yeah.
So you clone it, but then I'm just like,
yes.
I promise that this lives as long as, like if you give it some hints, it's like, no, this should live as long as this, and that's safe, and then it can go and tell whether you're correct in your assertion, and it's terrifying.
Yeah.
And the terrifying thing is, I think I like writing it as a hobby. If I could persuade my employer to take it up, I'd just be terrified that I'd be coding away and it would all be good, and I get to like a Thursday afternoon and I just get utterly stuck on some lifetime issue, and I'd be there for like 3 weeks. Like, what? Like, how do I make this? Like, all productivity stops where you're just fighting some borrow checker edge case or something for days, and you just can't get past it.
Yeah. So I love the error messages. I always say Rust error messages, it's like the compiler's just giving you a hug. Do you watch Taskmaster?
Very stupid. Yeah, occasionally.
You know, sometimes Greg Davis takes one of the comedians off and has a little chat with them, and the Rust compiler's like that. It's going, no, see, that owns that. So this thing can't change it, can it? No. So what are we going to do about this? Yeah, okay, you figure it out.
But it's not infantile. I mean, I don't find it quite so infantizing. But it is like the 6'8", because Greg Davis is huge, isn't it?
It's very helpful, let's put it that way.
Yeah, it is like the sort of, the granddad giving you a hug and saying, let me teach you some things about the world.
Yes.
Like, let's just, you tried, we all respect that. But if you're going to make it work, we just need to, maybe I'll give you some hints.
And I still remember sort of 40 years ago, having C compilers that would just go, nope, doesn't work, doesn't compile. I'm not telling you why not.
Nope, error one.
There is an error. It's in this file, it's at this line, and it's at this character. And actually it's not. It's 8 lines earlier. It's just that was the point at which C stopped being able to make sense of whatever garbage you'd thrown at it. Yeah,
the semantic ones, I mean, the very few, I remember the early C compilers would basically compile just about anything, as long as the syntax was okay.
Yeah.
They would let you do just about anything, even if that had like completely undefined effects, either in the C standard or on your CPU. Like, because nowadays they'll be like, oh, you might want to put a memory barrier in there. They never used to do that. I mean, nonsense. But the syntax, if you missed a bracket, they would just blow up, because one of the things the C standard is very clear about, because it's not clear about much. One of the things it doesn't specify a lot. One of the things it does say is you've got to be able to parse and compile this in one pass. Like the whole language is like, you've got to be able to start. That's why definitions are start. You've got to declare variables before you use them. You've got to declare functions before you use them.
Yeah.
Either a header file or static. You've got to be able to go through in one thing, and it goes top to bottom, and I think it was to save memory, so the compiler doesn't have to the syntax, the grammar is so simple that you never have to backtrack. Basically, you don't have to store any state in your compiler. In your Lexa. And I'm all forgetting the computer science degree I've got on type 1, 2, 3, 4 languages. It's one of those, and anyway. You would miss a bracket, and then it would, as you say, blow up like 10 lines later. And it was always those who were like, what have I done?
And it's kind of like missing, boom. And you're like, but it's there, look, they've got it. And these days, I use Visual Studio or Rider or VS Code, one of those three, or, the various JetBrains IDs. I wrote Kotlin for the first time a couple of weeks ago, which was a nice experience, actually. But I've got rainbow brackets installed on all these things. And so all my brackets are different colors. Well,
they just don't indent if you...
And I've got indentation lines and drawn on the UI and stuff.
You can tell if you've missed a bracket because the indentation will be wrong.
Yes, whereas back in the day it was VI.
It was Vim, but it couldn't do all that much.
VI on a monitor which couldn't do syntax highlighting because it was literally black and white.
You didn't even have an orange and black one. They were
so when I was junior, I had green and black. Then I went off freelancing for a bit for this company, and then came back and became the person in charge of the training program, taking on the new people. And at that point, I got promoted up to a Wace 120 amber and black.
There was a pecking order, right?
120 columns. Oh, it was.
Ooh, what are you going to do with the space? Well, the first, you just get screen and you just split it in half, don't you?
Yes.
Like, what would I do with all the 80 columns? My coding standard says 80 columns. There was no Git indication in the left. There was nothing.
I can't remember. But yes, that was
you set a white and black
.rc file for VI to tell it you've got 120 columns, because otherwise it assumes you haven't. So,
it's all better than, what was it? What was DOS? Abort, ignore, cancel.
Oh,
is that it?
Abort, retry, ignore.
Something like that. None of them made sense.
Abort, retry, ignore was the three choices, A, R, and C.
It was DOS, wasn't it?
But there was abort, retry, ignore, and cancel you used to get sometimes.
Yeah, you did, didn't you? No help, right? No documentation.
Yeah. It's,
you couldn't even Google, back then, you couldn't even Google, like, what on earth this meant.
To this day, when you try and close a Microsoft application without saving your changes, and it goes, you have unsaved changes. Do you want to save them now? Yes, no, cancel. And you're kind of like,
right.
It's only because I know that cancel says what you're cancelling is closing Word, closing Excel, closing Visual Studio.
Yes means save it and quit.
So yes, save it and quit. No, don't save it.
Throw my work away and quit. Yes.
Because I've made a terrible mess of that paragraph.
Yes.
And cancel is no, don't quit.
Yes. And I think the DOS ones were similar. They just use even worse words. So I think abort was stop trying whatever. You're trying to run a program. Abort was stop, and you can't read from the disk, right? Abort was like stop trying to run that program.
Yeah.
Ignore was the spicy one, actually. It was like the no equivalent.
Yes.
Ignore was it doesn't matter that you can't read. Like carry on. Like leave that piece of memory.
Do what you can.
Yeah, we're trying to read. There's a bad section on the disk. Leave that section of RAM uninitialized and basically set the program counter here and just execute whatever garbage was in RAM because you couldn't read it off disk. Ignore was the one that you actually didn't want to press.
Yes.
And then retry was obviously trying to read the disk again, and then I'd forgotten what cancel did. Maybe cancel was just like turn the system off,
just shut the whole thing down.
Yeah.
Yes. To be fair, all I ever actually used DOS for was playing Doom and Wolfenstein. So
typing win.
Yes, and typing win. God.
Typing win. Or you're closing Windows when you needed some RAM back to play Doom and Wolfenstein.
Yes, I'll tell you something when we stopped recording about Windows, the old win.com file, but it is not suitable for broadcast. So
interesting.
So yes, we should. So I think we've established that things move in cycles.
Yes,
and that's good.
Nothing is new.
And
some of them get better. Kubernetes is better than OpenStack.
Yeah.
.NET is better than it used to be.
.NET is better than .NET.
Yeah.
Kotlin is better than Java. Go is good.
Go is better than C.
Go is definitely better than C.
Like, it has problems, don't get me wrong. Every time I get frustrated with it, I'm like, no, this is C with the really worst bits fixed. And that's all it was actually ever meant to be.
Yes.
C with non-pointer exceptions and header file inclusion and stuff fixed, and that's fine.
It's better than C as a low bar.
Right.
Tropical diseases that are better than C.
Yes.
So yeah, we should do another one of these though.
We should. This has been really fun.
This is sort of an annual thing or something.
I'd love to talk about the comedy. I tried to do a funny about computers twice. I was thinking before we came up, and they were
Well, I was actually a professional.
Well, right,
for
exactly
some years, and it's great. Now I get to do both. I get to kind of be funny about computers.
It's just so much to this fish in a barrel, isn't it? It's just fish in a barrel a lot of the time.
So I'm working on a new one at the moment, Programming's Greatest Mistakes, which is kind of an in-depth analysis of things like the Y2K bug and just the very existence of null.
Null, the $1 billion mistake.
Yes, so that'll be showing up on YouTube sometime later this year.
I will check it out.
Right, cool, thank you very much.
Thanks very much.
It's really nice to meet you.
Yeah, thank you.